Hi guys and girls, welcome to my first YouTube video. Mrs McCurdy does science from self-isolation, not because I'm ill, but because I'm a bit old. And you'll see the little subtitle there, what could possibly go wrong? Well, quite clearly quite a lot. At the moment, the iPad is balancing on a television, and I'm trying to keep Rupert, the neighbour's cat, off of the dining table. So hopefully we'll get to the end of this video and all will be fine. So question 9.5 is what I want to look at. I don't have a copy of the paper, so I've literally just written out the key information, distilled it out of the question for you. 15.5 cubic centimetres of a 0.5 mole per decimetre cubed sulfuric acid completely reacted with 25 centimetres cubed of potassium hydroxide. We don't know the concentration of the potassium hydroxide, but we do know the molar ratios based on the balance symbol equation. And the question does ask you to calculate the concentration of potassium hydroxide in both moles per decimetre cubed and grams per decimetre cubed. So where do you start? So the first thing you need to do is convert your volumes, because at the moment they're in centimetres cubed and you want them in decimetres cubed. So to do that, you need to divide by 1000. Okay, so 15.5 divided by 1000 gives you 0.0155 decimetres cubed of sulfuric acid. Next thing, so that's the volume. Next thing is to calculate the number of moles of sulfuric acid. Okay, so moles equals concentration times volume. We've calculated the volume in decimetres cubed already. So the number of moles of sulfuric acid is 0.5 times 0.0155, which is equal to 0.00775 moles. There's your first mark. And that's just the first mark. Okay, the second mark comes from calculating how many moles of potassium hydroxide reacted. That's the second mark. So how do we calculate that? Well, that comes from this equation at the top. 2 moles potassium hydroxide react with 1 mole of sulfuric acid. So we've got 0.00775, so it's 2 times 0.00775 moles of H2SO4, which is equal to 0.0155 moles of KOH. Okay. Now, the next step is to calculate the concentration of potassium hydroxide. Now, concentration is equal to moles divided by volume. Okay, now we have our number of moles and we have a volume of 25 cubic centimetres. But we can't use 25 cubic centimetres, we need to use a decimetre cubed value. So again, we need to work that out. But your concentration that you've got, just to show you, is 0.0155 moles in 25 centimetres cubed. So although we can work out this, what we actually want to know is how much is in a decimetre cubed. So we've only got an aliquot here, a small amount, 0.155